Shalom class. We are now focusing on quadratic graphs, right? We want to polish quadratic graphs, right? This question was extracted from June 2018 paper 2. It reads, the following is an incomplete table of values for y is equals to half open bracket 15 minus x squared. Calculate the value of m. This is part 1. Calculate the value of n, part 2. Right. So to find the value of m, it is very simple. You just need to check the value of x, which is aligned to m, and this value of x is minus 3. So on your graph, you put minus 3 for x. So m is equals to 1 over 2, open bracket, 15 minus open bracket, then you put minus 3 on x, you raise by power 2, you close your bracket. So this can be punched once using your calculator. Then if you want to work it manually, you have to be very careful of signs. Remember, any negative number raised by power 2 becomes positive. So minus 3 squared, you don't get minus 9, but you get plus 9. I hope you are following. Then 15 minus 9, it gives you 6. Half of 6 is equals to 3. So it simply means that m is equals to 3. I hope you are following, class. We move on to n. The value of x aligned to n is 2. So to find n, you need to put 2 on x, right? So n is equals to half, open bracket 15, minus open bracket 2 squared, something like this. Half, open bracket 15, where 2 squared gives you 4. So 15 minus 4, you get 11. And half of 11 is equals to 5,5. So n is being represented by 5,5. So I'm going to write 5,5 here. So you get 2 marks for that. We move on to part B of the question. Draw the graph of y is equals to 1 over 2, open bracket 15, minus x squared, 4 marks. Right, so we are given the graph on page 17, and the scale is given already, which is 2:2 on both axes, right? So to draw the graph, we make use of the table of values, right? The first point that we have is minus 4 for x and minus 0,5 for y. So you need to start your scale, right? If your scale is 2, 4, 6, it simply means that one small box represents 0,2, right? So we need 2 small boxes and a half to get 0,5, right? So this is minus 4 for x, but under minus 4, we need 2 small boxes and a half. So 1, 2, and a half. So somewhere here. That's where our point lies. 1, 2, and a half. Right. Then we move on to the next. We have minus 3 for x and 3 for y. So minus 3 is a number which is between minus 2 and minus 4. You count 5 small boxes. 1, 2, 3, 4, 5. This is minus 3, right? To be aligned with 3. And 3 is between 2 and 4. So you count 1, 2, 3, 4, 5. Somewhere here. You mark your point. 1, 2, 3, 4, 5. Right. So this is minus 3 for x and 3 for y. Then we move on to minus 2 and 5,5. Right. So firstly, you need to identify the position of 5. For 1, 2, 3, 4, 5. This is 5, right? So if we add one small box, you get 5,2. If you add another one small box, this is now 5,4. So 5,5 is 2 boxes above 5.5 somewhere here. So we want this point to be aligned with minus 2. So this is your point here. Where is minus 2? This is minus 2, so your point is somewhere there. So this is your point. Minus 2 for x being aligned with this point. Right, then we move on to minus 1 and 7. Minus 1 is between 0 and minus 2. You count 5 small boxes. 1, 2, 3, 4, 5. So you get your minus 1 here. So 7, we are going to get 7. 5 small boxes above 6. 1, 2, 3, 4, 5. So this is my point. I hope you are following. Right. Then we move on to 0 and 7,5. This is 0, 7,5. We need 2.5 boxes above 7. So this is 7, 1, 2.5, somewhere here. You put your point. Right. Then 1 and 7. 1 is between 0 and 2. 1, 2, 3, 4, 5. This is 1. 1, 2, 3, 4, 5. This is 1. So let me use a ruler. 1, 2, 3, 4, 5. So this is 1, right? This is 1. To be aligned with 7. 7 is 5 small boxes above 6. 1, 2, 3, 4, 5. So here is the point. Here's the point. Right, then we now need 2 and 5,5. So remember 5,5, we obtained it already. This is 5,5, but the sign is now being aligned with 2. This is 2, right? This is 2 and 5,5, somewhere there. You get your 5,5. Right. Then we move on to 3 and 3. So this is 1, 2, 3, 4, 5, right? And 3 for y. 1, 2, 3, 4, 5. So this is where your point lies. Right. We move on to 4 and 0,5. So this is 4, 0,5. We need 2 small boxes and a half under 4. 1, 2 and a half. Then you draw. Right. You connect. Right, so this is your parabola, the way it is supposed to come out. Like, right, you get 4 marks for drawing the graph. Right, we move on to the next part of the question. Part C1 of the question. Find the equation of the line of symmetry of the curve. Right, so the equation of line of symmetry is a vertical line, right, which cuts the graph into 2 equal parts. Right, so you can clearly notice that our graph is being cut into 2 equal parts by this y-axis. Right, so y-axis is the mirror line or the line of symmetry, but you don't give your answer as y-axis because the question wants it in form of an equation. So another name for y-axis is x is equals to 0. So on your answer for the equation of line of symmetry, you write x is equals to 0. I hope you are following. Right, so I'm going to write x is equals to 0. Then you get yourself a single mark for that. Right. We move on to the next part of the question. Estimate correct to 1 decimal place the solution of the equation 1 over 2 open bracket 15 minus x squared is equals to 2 marks. Right. So when solving equation, you first of all look at the left side of the equation if it is similar to the graph that you have drawn in part B. So if it is similar, it simply means that your values or the roots of x are going to be found at the point of intersection between your graph and the line y is equals to 2, of which y is equals to 2. We have drawn that line already. So this is y is equals to 2. It is cutting our graph at this point and at this point, right? So how many small boxes do we have in front of 3? Firstly, let us identify the position of 3. 1, 2, 3, 4, 5. So this is 3, right? So how many boxes in front of 3? 1, 2. We have 3 boxes in front of 3, of which one small box is being represented by 0,2. So it simply means that our first root is equals to 3,4. We now need the second root, right? So the second point of intersection is this point, right? How many? 1, 2, 3, 4, 5. 1, 2. You need 2 boxes in front of minus 3. So our second solution is minus 3,4. So this is how you present your answer. 3,4 or minus 3,4, something like this. I hope you are following class. Right, then we move on to part 3 of the question. It reads, find the gradient of the graph of y is equals to 1 over 3, 15 minus x squared at point x is equals to 2. Right, so you draw a vertical line first from x is equals to 2, heading towards your graph, something like this. At this point of intersection between this vertical line and your graph, you put a spot so that you draw a tangent which touches this spot. I hope you are following class. So I want to draw my tangent here. Something like this. So this is a tangent. So a tangent is a line which touches that point, but it is not allowed to cut inside the curve, right? So this point is 2 and 5,5. You can clearly notice it from the table of values. That 2, right? The corresponding value of y is 5,5. So this point is 2 and 5,5, this one, right? Then our tangent is cutting between 4 and 6. So this point is 5 for x and 0 for y, right? So to find your gradient, you make use of the formula m is equals to y2 minus y1 divided by x2 minus x1. So our first point is 2 and 5,5. Then our second point is 5 and 0. So this is x2 and y2, something like this. So on y2, I'm going to put 0 minus y1 is 5,5. On x2, I'm going to put 5 minus x1 is 2. I hope you are following. So you have minus 5,5, then 5 minus 2, you get 3. So your final answer is minus 1,832 significant figure. If you divide minus 5,5 with 3 using your calculator, this is what you get. Right, then there are some questions that you may come across in line with this graph. You can be asked to find the maximum value of y. So if you are asked to find the maximum value of y, you draw a horizontal line at the peak point of your graph. So you can clearly notice that this line is cutting at 7,5, right? So the maximum value of y becomes 7,5. I hope you are following class, right? But there is a difference between maximum value and maximum point. For maximum point, you need the x coordinate and the y coordinate at the peak point of your graph. So the x coordinate is 0, right? So you write 0 and the y coordinate is 7,5. So maximum point becomes 0 and 7,5. I hope you are following. Right. Then another question that you can be asked is to find the area under the graph. Right. So you can be asked to find the area bounded by the curve, the y-axis, as well as the x-axis. Let's say from x is equals to 0 to x is equals to 4. Also bounded by the y-axis as well as the x-axis. All right. So this is your y-axis and this is your x-axis. They are referring to this region. Let me label it R, from this point 0 up to this point 4. Right. So you divide this region into two shapes. This is shape A and this is shape B. We have two methods. Someone can make use of the trapezium method or the counting of square method. Right. So the easiest way, you can make use of the trapezium method. To find area under A, since A is a trapezium, you are going to make use of the formula half A plus B times height. So from this 0 up to this peak point, you have 7,5. I hope you are following. Then from this point up to this point, you have 5,5. So this is 5,5. Then from 0 to 2, you have 2. So 7,5 and 5,5, they represent A and B. And this 2 is going to represent your height. So half 7,5 plus 5,5, then your height is 2. So 2 and 2, they cancel off each other. Right. So 7,5 plus the 5,5, you get 13. So 13 square units is the area bounded under shape A. Then shape B is not a trapezium. Shape B is a triangle. So to find area under B, you make use of half base times height. So your base is from 2 to 4, which is 4 minus 2, you get 2, right? And your height is 2,5. So half base 2, and your height is 5,5 actually. 2 and 2, they cancel off each other, leaving you with 5,5. So the total area is then found by adding 13 and 5,5. Your answer is 18,5 square units. So this is how you do to find the area bounded by the x-axis, the y-axis, as well as the graph, from the given x is equals to 0 to x is equals to 4. I hope you are following. Right. Basically, that's the idea. Right. But you can also come across with a question which may ask you to solve this equation. 15 minus x squared is equals to x plus 2. Right. So since the left side is similar to the graph that we have drawn in part B, you now need to draw a line which is called y is equals to x plus 2. The point of intersection between y is equals to x plus 2 and your graph is going to lead you to the answers. So how do you draw y is equals to x plus 2? You make use of table values to find the value of y when x is 0, as well as the value of x when y is 0. So if you put 0 on x, y becomes 2. If you put 0 like y is equals to 0 plus 2, you get 2. If you put 0 on y, you get 0 is equals to x plus 2. But moving 2 to the left, it gives you minus 2 is equals to x. So you have 0, 2, and you have minus 2, 0. So this is 0, 2 here, and this is minus 2, 0. Then you take your ruler, then you draw a line. So the point of intersection of this line that you have drawn and the graph is going to lead you to the answers. So here, if you can see clearly, you can notice that we have 2 boxes in front of 2. Hence, our first solution is going to become 2,4. Right. Unfortunately, this line is not cutting our graph here. since our graph is starting from this point. But for such questions, you will notice that your graph will be cut twice by this line, meaning to say that the second solution will then come here, of which you have got two boxes in front of -4. It simply means that your second solution becomes -4, 4, since one small box is representing 0,2. I hope you are following, class. Right. They can ask you to find the range of possible values of y for which your graph is positive. Right. So the range of possible values of y for which the graph is positive. Let's say this is our graph and we have -2 and we have 6 here. So your answer becomes -2 less than the range of possible values of x for which y is positive. So you write -2 less than x less than 6, and this is your answer. We'll be requiring this region which is above the x-axis. So the range of possible values of x for which y is positive, they start from -2 up to 6. I hope you are following, right? So basically, that is the idea that you need to understand for quadratic graphs.